Welcome. Today we're going to be talking briefly about naming acids, and then I'm going to go over something I'm calling the Rosetta Stone of compound nomenclature. Nomenclature, of course, means any system of naming something, and in this case we're talking about chemical compounds. So this is what you've already been talking about in a word you've seen before, but because the reason I call this little piece of paper the Rosetta Stone is because it helps to put everything together. Of course, historically, the Rosetta Stone helped to crack the code of the Egyptian language because there were 3 different languages all on the same stone, and that helped us to figure out what the meaning of the Egyptian characters were. So in this case, hopefully this document will help you figure out the meaning of the names of acids. So the first question, when we are naming acids, how do I know it's an acid? Okay, so let's do a little drum roll here. The answer is, the first element is hydrogen. That's the only thing you have to remember right now. In order to know that something is an acid, all you do is look at the first element. If it's hydrogen, then you assume it's an acid. Okay, now I'm not going to say that this is 100% correct rule, okay, because there are some exceptions, and one exception is going to be this one right here that you might have heard of before. Okay, this compound right here called H2O or water is not an acid. Okay, so this would be an exception. Everything else you see pretty much will be an acid if the first letter is an H. Let's go through some examples. Which of these are acids? Obviously, this is not an acid because it doesn't start with H. This one is an acid because it starts with H. This one also is an acid. It also starts with H. This one, now you've seen this before, C6H12O6 in biology. This was called glucose. This is the necessary element to start cellular respiration, or the necessary compound, I should say, to start cellular respiration. And it's an important compound, but it does not start with H, and it is not an acid. And this final one here has 3 H's, but they don't come first, therefore it is not an acid. We only have 2 acids here. In the next slide, we'll learn how to name these. Okay, there are a few rules for naming acids, or a few steps, I guess I should say. The first one is we have to find the anion by taking away the hydrogens. Okay, so we treat these kind of like they are ionic compounds, okay, and kind of like we have positively charged hydrogens coming together with anions. In the first case, this anion would be bromine. Okay, so if we look at it that way, then one way we can do this is we can go backwards on what we did before. Okay, we assume we've got these little subscript 1s, because if there's nothing there, then it must be a 1. And we put this up here and this up here. Okay, so we find the base anion. In this case, the base anion is bromine. Then we just ignore the hydrogens, frankly. We don't even have to really worry about, it's always a 1 positive charge on hydrogen. But the main thing is we just have to figure out what the base anion is, because that's what we're going to use for naming this acid, for naming HBr. Okay, we're going to use this anion. Okay, and that anion is called Bro. The next one, okay, H2SO4. Take the 2 by the hydrogen and put it up here. Just so you know, you might know that already. SO4, 2 negative. Aha, that looks familiar. I've seen that because I'm getting ready for my polyatomic ion quiz that's coming up. As you guys all know, this is called Sulfate. And finally, this, of course, has a 1 here, goes up here. This is NO2 negative nitrite. We're going to be looking at these endings. That's going to be the key here. Okay. Look at the ending of the anion. If the ending is "ide," the name is hydroblankic acid. If the ending is "ate," the name is blankic acid. And if the ending is "ite," the name is blank-us acid. All right, so let's start with ide. Okay, if the ending is ide, the name is, so let's see, do any of these have ide? Of course, the first one has ide, so the name is going to be hydrobromic acid. See, now I followed this exactly. I put hydro, okay? And sometimes we might wonder what goes in this blank. It's essentially the first one or two syllables. And sometimes it'll be one, sometimes it'll be two. It's just kind of something you have to get used to. And over time you'll figure it out. But here's the key is if you put one syllable and you should have put two, or you put two syllables and you should have put one, I won't care. It'll be completely fine. You'll still get full credit. The main thing is I want to see hydro, and I want to see an ending that ends in ic. That's what I care about. Now, if the ending is 8, when we look at the base anion, if the ending is 8, then we must have, then what we have to do is, all we have to do is put the first one or two syllables and then add ic acid. Now, in the case of this one's a little bit different. Some people might look at this and say, okay, this must be called sulfic acid. If you put sulfic acid, you'd be completely fine. I would give you credit. But just from having seen this many times, I know that the way we name this is sulfuric acid. Okay, and the key here is having that ic on the end and making sure that you don't put hydro in this case, because if you have hydrosulfuric acid, that is a totally different acid than sulfuric acid. This is sulfuric acid. I'm going to even write it down here so that we're really clear. And this one was HBr. And then finally, if the ending is ite, okay, so the ending of the base anion is ite, which this is ite right here, then the name of the acid is nitrous, or it's us, blank us acid. In this case, we put NITR, nitrous acid. And that, of course, would be HNO3. Okay, ignore those little lines that come off. I'm not sure why this program does that. A little more practice. We're going to be going backwards here. Okay, if we have something called nitric acid, okay, ic. So if it's ic, now look at this. If it's ic acid, blank ic acid, then the ending of the base anion must be 8. Okay, so our base anion then must be NO3 negative. Okay, because that is nitrate. And of course, to make it an acid, we've got to put some H's on it, and they come in the form of a positive hydrogen. And so we just put this here, and that comes out to be HNO3. Okay, this next one is H3PO4. Okay, what do we have going on here? We have to figure out what that base anion is. All we really need to do is take this 3, put it up here. We're going to get PO4 negative is the base anion. We essentially can ignore the hydrogens because they're not going to play into the name at all. The hydrogens essentially just indicate that we have an acid. Okay, so PO4 negative, we know that's called phosphate if we follow our rule. If it ends in 8, then all we do is we put ic, we put blank ic acid. And in this case, we could have called it, it might make sense to call it phosphoric acid, though in this case it is phosphoric acid. And again, if you put phosphoric acid, I'm going to be fine with that. Obviously, over time, you want to learn the proper way to say it, but as long as you're following the rules, I'm going to be cool with it. All right, again, here we put this here. Okay, we've got ClO4 negative. This is called chlorate. And so if it's chlorate, then when we turn that into an acid, it's going to be called chloric acid. Now we've got something called hydrosulfuric acid. Okay, now if it has hydro in the name, then the ending of the base anion must be IDE. Okay, so IDE, well, usually that's monoatomic anions that end in IDE. In this case, we've got sulfur we're working with, so we're going to put S2 negative. Okay, and of course, we've got to combine that with hydrogen somehow. We put that here and that here. We've got H2S. So this is called hydrosulfuric acid. Finally, HCl, our base anion, is chloride and ends in IDE. And so we have to put hydrochloric acid. And that's the name of that. Boom. Not too bad. All right, now, this is what I'm calling the Rosetta Stone of compound nomenclature. It's just a simple flow chart that helps you to determine what the name is of most simple compounds. Okay, and you'll find how easy it is. Let me give you an example. Let's start with this first compound. All right, MgCl2. We have to answer one question to get started. It says, it's essentially, the question is, what is the first element? If the first element in the compound is a metal, then we do this. If it's a hydrogen, then we do this. If it's a nonmetal, then we do this. In this case, the first element is magnesium. Now, is that a metal or a nonmetal? Or is it a hydrogen? Obviously, it's not a hydrogen. Let's look at our periodic table. Magnesium is right here. And that first element, obviously, it's to the left of the staircase. Right over here is the staircase. Right over here is the staircase. So that's obviously to the left of that. So therefore, it must be a metal. Sorry, let's go back to that. It must be a metal. And so if it's a metal, then we know we have an ionic compound. Okay, so then what we do is we name the metal. If it's a transition metal, we need Roman numerals. This is not a transition metal because transition metals would be these metals in here. So this is instead, it's an alkaline earth metal. And so we just name the metal, and then we name the nonmetal, and we have an ending that is either "ide," "ite," or "ate," depending on what that anion is. So let's just figure out what the anions are really quickly. So we've got that and this up here. So our anions are Mg2+ and Cl negative. Magnesium and chloride, the name is magnesium chloride. Make sure this is clear. That's an M on the end. It just got a little sloppy. All right, next one. Okay, let's look at this compound. It starts with an H. All right, then we go right here. This must be a acid. Okay, so the key here is acid. It ends in acid. Okay, so now we need to, let's do a quick crisscross in order to figure out what the let's see, no, not that one. Hold on. Okay, let's do a quick crisscross here. Again, we're not really concerned. Once we use the hydrogen to just simply determine it's an acid, we don't really use the hydrogen anymore in the naming of that acid. Okay, we just assume once it's an acid, then we use some different conventions to be able to figure out what the name is of that. We start with what the base anion is, which is CO32-. That's called carbonate. Okay, and if it ends, let's look at this rule down here. 8 goes to ic. Okay, carbonate goes to, okay, so we must have carbonic acid. If you would have put carbic acid, I would have been fine with that. That's not a problem. That should be an R in there. Carbonic acid. Okay, now, the next one here, let's just figure this out quickly here. It is SO3 2-. Now, hopefully you've been studying this because you will figure out that this is sulfite. ITE. Look down here. ITE goes to us. We can actually call this sulfurous acid. And if you would have put sulfus acid, you would have still gotten full credit. But the correct name is sulfurous acid. Now the next one here, phosphorus. Is this a metal or a nonmetal? Obviously it's not hydrogen. Let's look on our periodic table. Phosphorus is right here. That is a nonmetal. Okay, so we're going to follow these rules. That means these rules here. We use prefixes to denote quantity. And we don't do any crisscrosses, we don't do any charges, we don't use mono on the first element. Okay, so this must be phosphorus. We need to use these prefixes, trichloride. Phosphorus trichloride. Ignore that funny looking line again. It's getting kind of annoying, honestly. Okay, now the next one here is dinitrogen pentoxide. All right, di means 2, pent means 5. So we've got 2 nitrogens and 5 oxygens. Of course, we know that nitrogen is a nonmetal, and so that's how we figured out that this was dinitrogen pentoxide. Next one starts with an H. Oh, we must be talking about an acid and ends with an I. Okay, so let's break those out and figure out what the base anion is. It's I negative. That is called iodide. Okay, so it ends in IDE, iodide. Ide goes to hydroblankic acid. So I'm going to call this hydroiodic acid. Okay, now finally, this one's a little bit more involved. You're going to want to be ready for these. They're not that hard, but the first element is iron. Where is iron? Okay, iron is right here, number 26. And something important is this is in the transitional metal area. Remember, transitional metals, let's look on this list. It says if we have a transitional metal, then they get Roman numerals. Okay, so we need to put a Roman numeral to indicate what the charge is on the iron. Now, why are we doing that? The reason is because the transitional metals, those elements can have different charges on them. Okay, so in other words, iron could be either a 2+ charge or a 3+ charge. And whoever is looking at this needs us to tell them whether or not that was, whether that was a 3+ or whether that was a 2+. So let's figure out in this case, all we can do this crisscross thing here. And we're getting Fe 3+ and O2 negative. Those are our two ions. And so here on iron, we put iron. We need to have Roman numerals, so we go 1, 2, 3, and oxide. Okay, so this 3, Roman numeral 3 means that we have iron with a 3+ charge. If it would have been a 2+ charge, which it would have been had we had, for example, FeO, then it would have been iron 2 oxide. But in this case, we had iron with a 3+ charge, so that made iron 3 oxide. All right, so that hopefully helps you figure out how to use this flowchart. I'm going to allow you, if you want to, I'm going to allow you to use this on a test, this flowchart over here, okay, this Rosetta Stone of naming compounds. But if you have a question, come in and ask me. I know that because it's very brief, it might at first seem to be a little bit difficult to follow, but once you get it down, you're going to find this information is very valuable, very to the point, and helpful in naming almost any common compound. That will conclude it. Come in and ask any questions that you have, and I'll see you next time.